Assalamualaikum everyone, my name is Mohammed Abdul Azal, roll number 21 TE53. Today we are going to discuss Lab 12 of DSP under the supervision of Dr. Engineer Muhammad Jameel Khan. Starting with Task 1. Task 1, as we given the DSP system YFN with initial conditions and the input. So we have to compute the system response YFN for 20 samples. As you can see in the source code, we have sampling rate. In step 1, design the analog filter. In step 2, convert to digital filter using bilinear transformation, and then plot the magnitude and phase response. At the end, create a new figure for phase response. Convert phase to degrees. Now we run this code. This is the output image of phase response of Butterworth's low pass filter. Now moving forward towards task 2, we have impulse response, numerator coefficients of h of z, denominator coefficients of h of z. Then we have step response, input signal. In input signal we have time range, input signal x of n. Then we find system response, and at the end we plot the signal as given. And now we run the code. This is the output image of impulse response, step response and system response. Now moving forward towards task 3 of lab 12. Firstly we define the numerator and denominator coefficients, then create the transfer function object that plots poles and zeros. At the end we calculate and plot frequency response. After running this we see the output image. This is the frequency response and this is normalized frequency of the given function. Now moving forward towards task, this is the poles and zeros observation for task 4. Task 3. Now moving forward task 5, we have to define the system coefficients, numerators and denominator coefficients of y of n, then set the sampling rate. After that we have to compute the frequency response, taken that in number of frequency points, then plot the magnitude response and plot the phase response of the system. After running this code we have the output image of phase response of the system, and this is the frequency response of the system. Now towards task 6, define numerator and denominator coefficients, create transfer function object, plot poles and zeros, calculate frequency response and plot magnitude response. At the end plot phase response, identify the filter type based on frequency response. After running this game we find all the magnitude frequency response, phase frequency response. This is poles and zeros observations. Now towards task 7 of lab 12, we have filter 1 coefficient. We have two filters. These are the filter 1 coefficients and these are the filter 2 coefficients. Create transfer function objects, plot poles and zeros for filter 1 and plot poles and zeros for filter 2, and then compare. At the end compare the results. Now we are going to run this code. This is filter 1 poles and zeros configuration and this is filter 2 poles and zeros configuration. Now moving forward towards task 8 of lab 12, we have two filters, filter 1 and filter 2 and filter 3. We have to compare their results. We simply run the code and check the output.